Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
As a parent or mentor, you have the awesome opportunity to help a young person build a future. So if the future they want is in the military, take the time to learn more at todaysmilitary.com, because their success tomorrow begins with your support today.
This is SpaceTime Series 24, Episode 71, for broadcast on the 23rd of June 2021. Coming up on SpaceTime, another step in understanding the differences between matter and antimatter, volcanic activity on Venus, and scientists develop a model of the Milky Way's central black hole. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Physicists using the world's largest atom smasher, the Large Hadron Collider at CERN, have for the first time measured a difference in mass between matter and antimatter versions of a subatomic particle called a D0 meson. The authors measured a difference in the mass between the two types of D0 mesons of 10 to the minus 38 grams. The findings, reported in the journal Physical Review Letters and on the pre-press physics website archive.org, represent a major milestone in efforts to determine how a D0 meson can flip into its antiparticle state and back again. This extraordinarily precise measurement was made by researchers with the LHCb collaboration, located at one of 4 cathedral-sized detectors spaced around the 27-kilometre Large Hadron Collider ring located beneath the Franco-Swiss border. Mesons are made up of fundamental particles called quarks and contain one quark and one antiquark, the antimatter counterpart to the quark. The D0 meson consists of a charm quark and an up antiquark, while its antiparticle, the anti-D0 meson, consists of a charm antiquark and an up quark. D0 mesons are one of only 4 known particles in the standard model of particle physics that can turn or oscillate into their antimatter particles, which are identical to their matter counterparts in most ways. The other 3 are the K0 meson and 2 types of B mesons. In the strange world of quantum physics, just as Schrödinger's cat can be here and gone at the same time, the D0 particle can be itself and its antiparticle at the same time. This quantum superposition results in 2 particles, each with their own mass, a lighter and a heavier D meson, known technically as D1 and D2. It's this superposition which allows the D0 to oscillate into its antiparticle and back. The D0 particles were produced in proton-proton collisions at the Large Hadron Collider and travel on average for just a few millimeters before transforming or decaying into other particles. It was data collected during the second run of the Large Hadron Collider, which allowed researchers from the University of Oxford to measure a difference in the mass between the 2 particle types. By comparing the D0 particles that decay after travelling a short distance with those that travel a little bit further, the LHCb collaboration has measured the key quantity that controls the speed of the D0 oscillation into anti-D0, the difference in mass between the heavier and lighter D particles. And that result crossed the 5 sigma level of statistical significance required to claim a new discovery in particle physics. The new observations of this mass difference will allow physicists to delve into whether these transitions are caused by unknown particles beyond the standard model, the foundation underlying science's understanding of the universe. If these new yet-to-be-discovered particles exist, they could increase the average speed of the oscillation, or the difference between the speed of the matter-to-antimatter oscillation and that of the antimatter-to-matter oscillation. If observed, such a difference could shed light on why the universe is made up entirely of matter, even though equal amounts of matter and antimatter would have been created in the Big Bang 13.82 billion years ago. Antimatter has the opposite electrical charge of matter. So, the antimatter counterpart to the positively charged proton is the negatively charged antiproton, and the antimatter counterpart of the negatively charged electron is the positively charged positron. The problem is, matter and antimatter annihilate each other when they come into contact. So, The universe should have annihilated itself in a sudden blue flash of gamma rays virtually as soon as it came into existence. Yet, clearly that didn't happen. We now live in a universe composed mostly of matter rather than antimatter. Chris Parkes from the L8CB collaboration explains the significance of the new result.
All the basic fundamental particles of nature, they have a matter version and an antimatter version. And what we do here at L8CB, one of our specialities, is looking at the difference in properties between matter and antimatter. Now, the result that we've released today is looking at a particle called a D0, which contains charm and up quark, and the antimatter equivalent of this, the anti-D0. And what we find is that this D0 particle can oscillate into its antimatter equivalent by some fascinating quantum mechanics. The rate at which this oscillation between the D0 and the D0 bar happens depends on a tiny mass difference between particles. This tiny mass difference is 10 to the minus 38 grams. That's 0 followed by 37 zeros, 1 grams. And it's this tiny number which is controlling the rate of oscillations between the D0 and the D0 bar. Now, actually, this is controlled by some really fascinating quantum mechanics. And what's really happening is that we have a state which is a mixture of D0 and D0 bar. We have this, which is a mixture of D0 and D0 bar, and when we open the box at later times, maybe we see a D0, maybe we see a D0 bar. So it's a really fascinating result that we have today, but it's also a window for the future, because we want to use this to be able to study differences between D0s and D0 bars, between matter and antimatter, and we can study these differences between antimatter and matter using these oscillations that we've observed today.
That's Chris Parkes from the L8CB collaboration. The Large Hadron Collider, or L8C, is located at CERN, the European Organisation for Nuclear Research. It's part of a large complex of particle accelerators, synchrotrons and other high-energy laboratories. Packets of protons or other subatomic particles are accelerated to within 99.9999% the speed of light in opposite directions in two particle beamlines around the Large Hadron Collider ring, guided by cryogenically cooled superconducting magnets. The beamlines can intersect at any of the 4 particle detectors, colliding the particle packets at 13 tera-electron volts, creating the sorts of conditions, pressures and temperatures that occurred just after the Big Bang. In physics, an electron volt is a basic unit of particle energy, the amount of energy lost or gained by a single electron accelerating from rest through an electrical potential difference of 1 volt in a vacuum, which is 1.602 by 10 to the minus 19 joule. By comparison, energy from visible light ranges from about 2 to 3 electron volts. And thanks to Albert Einstein's famous mass-energy equivalence equation, energy equals mass times the speed of light squared, or E equals mc squared, as well as being a unit of energy, an electron volt is also a unit of mass in physics and astronomy, giving 5.61 times 10 to the 35 electron volts to the kilogram. This is space-time. Still to come, volcanic activity on Venus. And scientists develop a new model for the Milky Way's central black hole. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Scientists have found that some of the oldest terrain on Venus, known as tesserae, have layering consistent with volcanic activity. The finding could provide new insights into the enigmatic planet's geological history. Tesserae are tectonically deformed regions on the surface of Venus that are often more elevated than the surrounding landscape. They're thought to be the Venusian equivalent of continents on Earth. They comprise about 7% of the planet's surface and are always the oldest feature in their immediate surroundings, dating to around 750 million years. The new research reported in the journal Geology suggests that a significant portion of these tesserae have striations consistent with layering. The study's lead author, Associate Professor Paul Byrne from North Carolina State University, says tesserae are either made up of volcanic rocks or their counterparts to Earth's continental crust. But he says the layering found on some tesserae simply isn't consistent with the continental crust explanation. Byrne and colleagues analysed images of Venus's surface from NASA's 1989 Magellan mission, which used radar to image 98% of the planet through its dense atmosphere. Scientists have been studying Venus's tesserae formation for decades, but the layering of the tesserae hasn't previously been recognised as widespread. And according to Byrne, that layering would not be possible if the tesserae were portions of continental crust. On Earth, continental crust is composed mainly of granite, an igneous rock formed when tectonic plates move and water is subducted from the surface. But granite doesn't form layers. If there is continental crust on Venus, then it's below this visible layered rock. And aside from volcanic activity, the only other way to make layered rock is through sedimentary deposits, like sandstone or limestone. But the problem is there's nowhere on Venus today where these types of rocks could form. The surface of Venus, 470 degrees Celsius, is hot enough to melt lead, with 99 times the atmospheric pressure at sea level on Earth. So the evidence right now points to some portions of the tesserae being made up of layered volcanic rock, similar to that found on Earth. The study is helping to shed light on Venus's complicated geological history. This is SpaceTime. Still to come, scientists develop a new model of the Milky Way's central black hole. And later in the science report, paleontologists identify a new species of large prehistoric crocodile that once roamed southeastern Queensland. All that and much more still to come on SpaceTime. Astronomers using new observations have developed a new model of the supermassive black hole at the centre of the Milky Way Galaxy. Most, if not all, galaxies contain a central supermassive black hole millions to billions of times the mass of the Sun. Located some 27,000 light-years away, with 4.3 million times the mass of the Sun, Sagittarius A star, the Milky Way supermassive black hole, is tiny by cosmic standards, but it's the biggest monster in our galaxy. However, it remains shrouded from our viewpoint on Earth by a veil of dense star fields and thick clouds of gas and dust. And that means understanding the structure of the environment around Sagittarius A star is based on very limited observations. Now astronomers using X-ray, infrared and submillimeter radio wavelengths have peered through these cosmic curtains to develop a simple physical model of Sagittarius A star. It shows material flowing into a dense plasma of electrons in a spherical region with a strong magnetic field around the black hole, and the subsequent compression and expansion of the hot gas producing infrared and submillimeter emissions, while scattering is producing powerful X-rays. The findings, reported on the pre-press physics website archive.org and in the Astrophysical Journal, can explain most of the features of Sagittarius A star's variability and the correlations between the X-ray, infrared and submillimeter radio emissions. When feeding, supermassive black holes are surrounded by swirling accretion disks of superheated material, stars and clouds of gas, gravitationally drawn in from the surrounding area. This material is crushed and ripped apart at the subatomic level, releasing massive amounts of energy which radiates out across the electromagnetic spectrum before the remains pass the black hole's event horizon, a sort of point of no return, beyond which material falls forever into the black hole's singularity, a place of infinite density and zero volume, where gravity is so strong not even light can escape, and science's understanding of the laws of physics breaks down. On the other hand, when they're not feeding, black holes become quiescent and invisible. Since the 1950s, astronomers have detected faint radio emissions emanating from Sagittarius A star. In fact, that's how it was first detected. Then in 1984, scientists monitoring the black hole began noticing variable infrared, X-ray and submillimeter radio wavelengths, occasionally flaring. And that suggests Sagittarius A star is accreting some material, although at a very low rate, probably just a few hundredths of an Earth mass per year. Still, by monitoring the variability of these emissions, astronomers have been able to measure the dimensions of the region based on the time it takes light to travel across it. Some of these flares have been measured to double in strength in less than 47 seconds. So that's the time period corresponding to the diameter of the black hole's event horizon. The findings agree with size differences made by other means using radio and near-infrared interferometry. To reach their conclusions, astronomers at the Harvard-Smithsonian Center for Astrophysics used observations from NASA's Spitzer Infrared Space Telescope together with simultaneous readings from NASA's Chandra X-ray Space Telescope and the submillimeter array over several decades to develop a statistical model of the relative timing of the flaring events and the frequency and duration of variability at each of the different wavelengths. They found that the variable emission seems to predominantly originate from a region about twice the size of the event horizon. They've also concluded that the same related physical activity is often producing multiple events seen at different wavelengths. The quantitative model also implies the presence of a dense plasma of electrons along with a modestly strong magnetic field. But the authors admit there's still a lot of questions left unanswered, including the origins of the strongest infrared flares and the reason for the long timescale of variability seen in the submillimeter wavelength. This is SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with the Science Report. New research shows that when you inhale isolated coronavirus particles, more than 65% of the deadly aerosols will reach the very deepest regions of your lungs. The findings, reported in the journal Physics of Fluids, suggest that treatments for the virus need to target the deeper airways rather than just the surface. While earlier studies have shown how the virus travels through the upper airways, including the nose, mouth and throat, this is the first study to examine how it flows through the lower lungs. The authors also found that more of the virus reaches the right lung than the left, especially the right upper and right lower lobes. That's due to the highly asymmetrical anatomical structure of the lungs and the way air flows through the different lobes. The World Health Organization now estimates over 8 million people have been killed by the COVID-19 coronavirus, with almost 4 million confirmed fatalities and almost 180 million people infected since the deadly disease first spread out of Wuhan, China. A new study has found that at least half of all the world's rivers are running dry at least once a year. The findings, reported in the journal Nature, show that river flow interruption is more common than previously thought. Researchers modelled the world's rivers, predicting that 51 to 60% of them have intermittent flows. It suggests that nearly all Australian rivers flow irregularly, except in areas of the west coast of Tasmania, while New Zealand's rivers tend to flow all year round. A new species of large prehistoric crocodile that roamed southeastern Queensland's waterways millions of years ago has been documented by paleontologists with the University of Queensland. Gunga Marandu Minella is based on an 80-centimetre long partial skull unearthed in the Darling Downs in the 19th century. The name comes from the local Aboriginal language, where the genus name Gunga Marandu means river boss, while the species name Minella means whole head, a reference to muscle anchoring apertures in the skull. The findings, published in the journal Scientific Reports, suggest the 7-metre-long crocodile fossil is between 2 and 5 million years old. A new study claims that ultra-high-density hard drives made with graphene can store 10 times more data compared to existing carbon-based technologies. Hard drives contain two major components, platters and a recording head. Data is written on the platters using the magnetic recording head, which moves rapidly above them as they spin. The space between the head and platter is continually decreasing to enable higher densities. Currently, carbon-based overcoats, layers used to protect the platters from mechanical damage and corrosion, occupy a significant part of the spacing. The new findings, reported in the journal Nature Communications, shows that you can replace the carbon-based overcoats with 1 to 4 layers of graphene. This enabled both increased data storage and provided a 2-fold reduction in friction and a 2.5 times reduction in corrosion and wear resistance. Microsoft's new Windows 11 operating system, our first test of the beta version of iOS 15, and Telstra now blocking 13 million scam calls a month. With details on these stories and more, we're joined by technology editor Alex Zaharov-Reutt from ITY.com.
Spam calls have just increased in volume, and they claim to be from government departments, they claim to be from Amazon or eBay, or they're trying any trick in the book. I mean, it's a numbers game. It's just like with spam. The reason why people still receive spam is because, sadly, enough people out there are still responding to spam and buying things from spam. And so if enough people can be caught via a phone call purporting to be from only takes a few, yeah.
I used to get these all the time. I found the best way to deal with them is to ask them to hold on for a minute and then just carry on doing your work.
Well, this is all part of Telstra's Cleaner Pipes initiative. And interestingly, only 3 months ago, they were blocking half the number. It's 13 million today, and it was 6.5 million 3 months ago. And Telstra has actually put out 5 things to watch for to protect yourself against spam calls. Obviously, you've got to be very careful, even though it might look like it's coming from a legitimate business or government organization, it might even have the correct number. Those sorts of things can be spoofed. Now, if somebody's trying to pressure you and say that it seems like it's urgent, well, also that's a big red flag. And if you really are concerned that some government department is onto you, don't accept the number that they're giving you on the phone. Look up their phone number on their website. I mean, grab the old-fashioned phone book if you still have one somewhere and ring that organization directly from their publicly available number. Also, are they ringing you during a weird time of the day, like on the weekend or late at night? Somebody trying to ring you repeatedly from an unknown number or purporting to be from a trusted brand. And obviously, if it sounds too good to be true, it probably is. And, if more people just went by that last golden rule alone, a lot of people would be much less in danger of being scammed.
Now, what I always do is I ask them to hold, and I'll be with them in just a sec. Then I go on and do whatever I have to do. And every now and then you'll hear this bleated hello in the background there.
Another trick is if they ring you and ask you, is there something wrong with your computer? You say, I don't have a computer. And you'll see how quickly they hang up. Also, if you ask them, is it Windows? And they say, oh, yeah, it's Windows. And then you say, well, I've got a Mac. And
oh, yes. Have you got your iOS 15 yet?
Yes, look, it's still the developer beta. It's not the public beta yet. I've been actually surprised. It seems to be quite stable, but then the initial betas, I guess, are like that. When they have the further betas with more features switched on, things can go a bit wobbly. I mean, you can actually have the release version of an operating system still have bugs that needs to be urgently fixed with a .0.1 or a 15.1, for example. But I've been enjoying how you can have multiple tabs open in the Safari browser. And instead of seeing a vertical carousel, you actually see tiles. So you see the browsers as little browser windows as little small tiles. Now, the address bar, instead of being at the top, it's now at the bottom where your thumb might be. And if you tap on it, the browser tab does go to the top. But the interesting thing you can do now is when you move your thumb up on the screen to move the page, the little tab window comes back at the bottom, and you can actually swipe left and right on that tab window to go through the different tabs you have open. So it makes it much easier to go through a bunch of different tabs you have open. But that's just one of the many features that are out there. I've been playing with the new version of Spotlight. Look, at the moment, there's only so many things you can do because I'm not using it on my primary phone. But thus far, it's been good. And I noticed when I come back to my iOS 14 phone that I missed some of these little features, especially in the browser, which is where I spend a lot of time. So I think as long as the bugs are well and truly squished by the time of launch, I think everyone will be very happy with iOS 15. And with iPadOS 15, I was playing with the ability to swipe up from the bottom right-hand corner with the stylus, and up pops the little notes. And also you can put the widgets now anywhere on the iPad home screens, whereas before you were only allowed to have them on the left-hand side. It's iOS 14 that allowed you to put widgets anywhere on the iPhone screen. It's come a year later, the iPad.
Now, this week, Microsoft are planning to launch the next version of Windows. Tell me about it.
Look, at the moment, it's all still rumors, but it seems to be a very strong rumor that Windows 11 will be the name. Already beta versions of Windows 11 have leaked. We're not sure whether they're newer versions or older versions. The Windows 11 seems to be very similar to the Windows 10X that Microsoft was going to launch with its dual-screen laptop. That version of Windows has been canned, and the dual-screen laptop hasn't made an appearance yet. But the Start button now opens up in the middle of the screen, and the icons at the bottom in the taskbar are now centered, which is a bit like what they have on the Mac. Reports say you can move the Start menu back to the left-hand side where it's been for a long time. Windows will also reportedly, and there are sounds you can listen to online, will have a start sound. Again, Windows 10 got rid of that, so Windows 11 will bring it back. But the biggest and most juiciest rumor of all is that Windows 11 will allow you to run Android apps directly as part of the system. Now, that's not confirmed. We don't know if that's the case yet. You can already use third-party Android emulators like BlueStacks and others to run Android apps on your Windows device. And if you have a Samsung device and you have the Your Phone plugin, you can run Android apps that way. But if Android apps come natively to Windows, that will give Windows a library of about 2 million phone and various Android tablet apps that it can run. So look, it's all yet to be confirmed. It will be confirmed. Whether or not Windows 11 will be available immediately or whether it will come in the future is yet to be seen. Presumably, it's a free upgrade. But it's also interesting because Microsoft said that Windows 10 would be the last name they'd ever give to Windows, and it would just be every 6 months there'd be an update. So obviously, the idea of that one went stale. They had to open the window to get in some fresh air, and the freshest idea they appear to have had is Windows 11. So we'll find out very shortly how true all of that is.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money, a Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.